Hi, so in this video, I'm going to discuss today's Leetcode weekly challenge. First and third problem: find the number of good pairs. Okay, so what is the problem statement? You are given two integers arrays num1 and nums2 of length n and m respectively. You are also given a positive integer k. Okay, a pair I comma j is called good if nums1 of I is divisible by nums2 of j into k. Okay, return the total number of good pairs. Okay. So first that problem initial this is actually a constant is less, so it will be easily solvable. Okay. So what is the problem? Like I will given a nums array nums 1, 3 and 4. Another nums array what is 1, 3 and 4. Okay. K is equal to 1. Okay. This is the array 1. This is the array 2. Okay. So what is they saying? I have to find out the number of pairs I comma j where nums of a1 of I by a2 of j into k. This is actually divisible by k, right? So modulo of this will be 0, right? So I will check with every pair. Like first I will check with this one with 1, then 1 with 3, then this with this, then 3 with 1 again, then 3 with 4, then 3 with this. Okay, again 4 with 4 1. Okay, so I will check actually every pair I comma j. So I will actually run two for loop. Like for loop I is equal to 0, this will run I less than a1 plus I plus plus, and another for loop that is I check all the second array nums array, where I will check that is this actually divisible or not. So I will check that if num array 1 of I modulo of array 2 of j into k is equal to 0 or not. If it is 0 is equal to 0 means modulo of this both are divisible, then I will increase the count answer plus plus and at the end return the answer. You got the logic, right? What is the brute force approach? So here actually I am running two for loop. One is to traverse the nums 1 array, and the second for loop is for traverse the nums 2 array. While checking the nums of 1, I modulo of nums 2 into j modulo of into k modulo of this is equal to 0 or not. If it is 0, then count answer increase the count answer plus plus, and at the end return answer. So that this means I will check with every I with 0 to n of nums 2. Got it? So this the time also to this will be n cross m. If this is the for n and this is for m, so for every element I am running this m times, so this will be n cross m. So for the third problem, the part 2, where actually nothing is actually different, problem statement is same, but their actual range is actually more. Okay, so n square will be not possible to solve this problem. So let's see some observation here. So I am saying that now a1 of I by a2 of j into k will be divisible by k, right? So if this have to divisible by this means like I am saying that a modulo of b is equal to 0, like 4 modulo of 2 is equal to 0. So 2 actually factor of 4. What is the factor of 4? Like what is the number of what is the possible number which is divisible by 4? One is 1, one is 2, another is 4. So if I get any number 1, 2 or 4, this will actually give like 4 with any number of this will actually divisible module will give us 0 remainder, means it will be divisible. So I will actually factor out all the like all the factor of each number of nums array 1. Okay, then what I will do, I will like for this example 1 3 4 1 3 4 and again 1 3 4 k is equal to 1. So what is the factor of this? Like one factor is only 1. Okay, what is three factor is 1 and 3. 4 factor is like 1 2 and 4, right? This is the factors of each number of this. So I am not traversing the array 2. Okay. So array 2 I'm traversing. So I first get 1. So 1 into k. So this will get 1. So which number will be divisible by this number? Which number? Whose factor is actually 1? Those number will be divisible by this. Like this will be divisible by uh, 1. This will be divisible by 1 because its factor is 1. Similarly for 4 will be divisible by 1 because this factor is 1. Because it has factor 1. So there will be 3 number for it will be divisible by this number. So answer will be currently 3 for this. Now come to 3. So 3 into k, so initially 3. So how many number will be divisible? How many numbers will be divisible by 3? Whose factor is actually, if I get any if I get any, like how many numbers whose factor is 3, this will be actually contribute, this number will be divisible. So here actually I see that only one number have factor as 3. So this will be actually contribute, so answer will be plus 1. Okay. Now I'll come to 4. 4 into 1, it will be 4. Whose How many number will be divisible by 4? So I have to find that how many numbers have factor as 4. So I will check, okay, only one number have factor as 4. So this will be again increased by 1. So ultimately answer will be 5. Got it? How actually, what is the logic? So first of find the factors of all numbers of nums 1. So I am just traversing like for x of nums 1, and I will factor will start from I is equal to 1 and I less than square root of x, then I plus plus. Okay, why square root x? So if suppose 6, what is the square root of 6? 2. So if I divide by 6 by 2, it will be 3. So it also divisible by 3. Like if this is divisible by, suppose x a by b divisible and c is getting. So I can actually pass like a by c will be b. So this will be same as the c will be divisible. C is the factor of again. So that's why if I pass the mid of the nums, that I will get the, if I reverse this, then I will get the, I don't have to traverse the whole. Otherwise, you can actually continue till x, not square root x. Okay, then you do not have to handle this situation. Okay. So I am checking that what is the factor. What will be the factor if modulo x modulo of I current number is divisible by I. That time will be, this is a factor. So I will just increase that one number have this factor. So I will just increase the count of that factor. Or how does it actually map? What will we actually answer? So I will just say that one factor have 1. Like one factor have only 1 numbers. Okay. Then I will actually check 1, like I will get 1 by x by 1, 1 by 1, it will be get 1. So I do not have to check any same factor. Okay. So I will skip. Next I will come as 3. So what is the factor? First I will check 1. Okay. So one factor, 2 number have as factor 1. So I will increase the count. Previously one factor was only 1 number. Now it is a 2 number. Now I will check what is the remaining, like 3 by 1. I will get 3. So again 3 factor as 1 number have as factor 3. Okay, got the map. Now I will come to the 4. So first I will come 1. Okay, so 1 factor previously it was 2, so it will be 3 now. Okay, because 3 number have 1 as a factor. 1 also have, 3 also have, 4 also have. Got it? Now come to next factor. Also 4 by 1, I will get 4. So previously I have not seen any number whose factor has 4. So it will be initial, now it will be 1. Okay. Now go to the next factor 2. Okay. So 2 is a factor. Okay. So 2 I have seen beforehand. No. So increase the count. Okay. 4 by 2. And 4 by 2 again it will be 2. So both numbers have the same factor. So 2 will not be counted as a double because only once it will be counted, right? So this is our current map. You got the logic how we get the factor map. Like how many numbers have this factor? Like 2 factors have only 1 number. 4 factor has only 1 number. 3 factors have only 1 number. 1 factor have 3 numbers. Okay. So I actually built this mapping. Now I'm traversing the nums 2. Okay. So what is the current factor? What is the denominator? denominator will be y into k. Y means the current nums2 of j, nums2 of j into k. Got it? Nums2 of j into k. So if this L2 divisible, if I some number have to divisible this number, so this will be some factor. So I'll check the how many numbers have this factor. So I'll go to the map. Suppose I first got 1. Suppose 1 into 1 I got 1. So I'll check how many numbers it have actually factor as 1. Okay, 3 numbers have. So I'll increase the count by this factor count y of y into k, it will get 1, and it will return as a map will still 3. So 3 number have as factor 1. Now go to the next 2. Suppose. So next we'll check, okay, means y into, after multiplying with y into k, I got 2. Suppose. I'll check how many numbers it will be divisible. So I will go to the factor how many numbers it have actually factor, okay, 1. So I will increase by 1. Got it? So the time also this actually the n into square root x, so n into root n, so it will be almost n square. Okay. Okay, root n also possible. Okay. And this is actually n, so this will be actually n square type almost. Okay, got it. And also got the logic how actually when the range is greater than, the brute force approach will not run, and how we are getting actually got the intuition that how we are actually got the factor logic. Like if if it has to be divisible, then this should be the numerator should be a factor. So I will just find out beforehand that how many factors it have actually, how many numbers. Got it? Thank you.